Let's see. It does say Friday, March 20th up top there, if you can see that okay. And it's homework number 380. And it's page 380. I scratched that out and did these numbers instead. So it's 1, 3, 5, 6, 8, 9, 10, 11. So here we go. I've got the lesson all written out for you. Let's go through it. The first part says, find a cubic equation with integral coefficients with given roots. All right, find a cubic equation. That means it's going to be x cubed. With integral coefficients, that means the coefficients are going to be like 5 and -2. There don't be any square roots or i's in the coefficients with the given roots. So they'll give you roots. I'm going to come back to this one. This one's more complicated. I'm going to start with the next page first. So same directions. This is like problems 1 and 1-3 on the homework. So in this case, here are given roots. They want a cubic equation with these two roots. Well, if it's a cubic equation, we need the third root. Here's our lesson for today. If 3i is a root, then -3i is also a root. You say, why is it written there and crossed out? I recorded this once, and I got almost all the way through it, and I didn't like how I was presenting it, so I started again. But you don't have to worry about that. Here's the deal. 4 is a root, 3i is a root. And what we're learning today, if 3i is a root, then -3i also has to be a root if the final equation is going to have integral coefficients. Because 3i is a complex number. It's really 0 plus 3i. We're in a plus bi form. If 0 plus 3i is a root, then 0 minus 3i is going to be the other root. If a plus bi is a root, then a minus bi has to be the other root. So if I gave you 4 plus 6i as a root, then 4 minus 6i would be the other root. So here we go. Our roots are 4, 3i, -3i. So if those are the roots, what are our factors? X minus 4, x minus 3i, x minus -3i, x plus 3i. So we've done that before. If you know the roots, you can come up with the factors. It's just x minus that particular root. X minus 4, x minus 3i, x minus a -3i, which is x plus 3i. So all you got to do now is multiply all that out together. A binomial times a binomial times another binomial. The order doesn't matter, but I think we're wise to multiply these two first. Why do you think that's the best way to go? Correct, because that's an FL situation, x minus 3i, x plus 3i. So if you FL that, you get x squared minus 9i squared. And I squared is -1, so that's x squared plus 9 times x minus 4. So x minus 4 times x squared plus 9, that's a clean FOIL. FOIL it out. Then I rearrange the exponents in decreasing order, and that's what we get. F of x or y equals that. Not too bad. Let's go back a page, because the previous one I think's a little more complicated. I think is more complicated. So in this case, cubic equation, and the roots are 1, and the other root's 2 minus 3i. Well, now we know if 2 minus 3i is a root, then 2 plus 3i has to be a root. So what are we going to write? We're going to write f of x equals x minus 1, x minus parentheses 2 minus 3i, x minus parentheses 2 plus 3i. Remember, it's always x minus the root. X minus 1, x minus parentheses 2 minus 3i, x minus 2 plus 3i. So we've got to multiply that. We've actually done this before, and I think the way that most of you kids preferred was to take this and distribute the negative through and get x minus 2 plus 3i. There it is. X minus 2. Oh, there it is. X minus 2 plus 3i is there. This one's x minus 2 minus 3i, which we wrote there. Just distribute this negative through, distribute it through. But now when you multiply, you get a trie times a trie. So you've got 9 multiplications to do. Maybe pause this if you want and do that out yourself, because here's what we get. We're just carrying this x minus 1 along for the ride. But this trinomial, You know how it works. X times negative 2, x times negative 3i, negative 2 times x, and so on. You get the 9 multiplications. They're all in here. And what happens is things cancel. The 3ix and the negative 3ix cancel. The negative 6i, the positive 6i cancel. Negative 2x and negative 2x is negative 4x. We have x squared. Then we have 4 minus 9i squared. And of course, negative 9i squared is negative 9 times negative 1, so that's positive 9, plus 4 is 13. So the bottom line, if you can see that, we had that x minus 1, which you carried along all the way, times this. Now you're still going to do that out. I'm not going to do it out because I ran out of space, but you can do that out, and what you get is your final answer. Okay. That's the page we already saw. And then for problems like 5, 6, 7, 8, here's the instructions. It says all but one of the roots are given. Find the remaining root. So they give you an equation. It's a cubic one here. And they say all but one of the roots are given. Find the other root. So the roots they give you are these. They say negative 2 is a root and 1 minus I is a root. Well, we've learned if 1 minus I is a root, what's the other root? 1 plus I. If one root's 1 minus I, the other root must be 1 plus I. That's it. That's it. That's all you have to do. Now, I'll show you a check here, but you don't have to check it. You can just trust if 1 minus I is a root, 1 plus I is the other. But if you like the check, here's what I did. I ran this root, negative 2, through the machine, 1, 0, negative 2, 4. And I ran it through, I got this, which is x squared minus 2x plus 2. And then I just solved that by quadratic formula, and you end up getting 1 plus or minus I. I won't spend time in the video going through the quadratic formula, but it's easy enough. You can pause it and go through it. You get this, which is 2 plus or minus 2i over 2. Reduce the 2's all around, you get 1 plus or minus I. Well, that's this is 1 plus I, 1 minus I. All right, but really, all you had to do was come up with that. All right, what else we got? The last few problems you do are similar. It says, excuse me, one root is given, solve the equation. I pause this to get a drink of water, but then I lose the video. I don't think I can pause it and re-record. All right. Solve this equation. It's cubic, and one root is given, and that root is I root 5. Well, if I root 5 is a root, then negative I root 5 is another root. Right, that complex conjugate thing? If 0 plus I root 5 is a root, 0 minus I root 5 is the other root. Just as we saw before. The fact that it has a root 5 on there is no big deal. All right, so what are we going to do? We got 2 roots, 1, 2. Solve the equation means we got to find one more root, right? 1, 2 roots, it's got to be 3. Find the third one. We got no choice but to run this through the machine. So I got I root 5, and across I got 2, negative 1, 10, negative 5. Let's just focus on this here. So we bring down the 2. 2 times I root 5 is 2I root 5. Add those. I have to write that as negative 1 plus 2I root 5. Multiply again. Negative I root 5 times negative 1 is negative I root 5. I root 5 times negative 1, negative I root 5. And I root 5 times 2I root 5. I root 5 times 2I root 5 would be 2I squared times 5. I times 2I squared. Root 5 times root 5 is 5. So there it is, 2I squared times 5. Well, what is that? I squared is negative 1 times 2 is negative 2 times 5 is negative 10. So this right here all becomes negative 10. Right? I squared is negative 1 times 2 is negative 2 times 5 makes it negative 10. Negative 10, positive 10 will cancel. I just have negative I root 5. Multiply one more time. I'll get negative I squared times 5. Right? Root 5 times root 5 is 5. Negative I squared times 5. So that's positive 1 times 5, which is positive 5, negative 5 makes 0. Wow. We had to get 0. It was a root, so we had to get 0. Well, now we're left with this equation with these ugly coefficients, but that's okay. We'll run negative I root 5 through that. We just ran this root through. Now we're going to run that root through. So that's negative I root 5. And now we're going to use those coefficients there. So